MSC Nastran Embedded Fatigue is about to be released, and this is a short video to explain the fundamental concepts behind the approach and to talk about some upcoming information days and training events that have been scheduled to go along with it. So what is Nastran Embedded Fatigue? It's the integration of fatigue calculations within a solver environment where dynamic response might be important. So this has been done before. GUI-based approaches for this, like MSC Fatigue, Design Life, FEMFAT, have integrated these three things before, but in those instances, fatigue has always been treated as a post-processing task. What makes this different is that fatigue is now part of the solve process. So by integrating the two things together, you get a number of very, very important benefits. This is a list of the main benefits. It's faster because the combined single process instead of the two processes gives much faster processing times. There are smaller file sizes involved, which is a big advantage. It's simpler because of the removal of a lot of intermediate files. It's portable because the whole thing is defined in a single input bulk data file. It's transparent because the instructions needed for a particular fatigue calculation are very clear. And it gives the option of better designs because optimization SOL 200 can be included with a typical fatigue job. So going through these one by one, why is it faster? Well, with a conventional GUI-based fatigue calculation embedded inside of the CAE environment, you run a Nastran job, you generate your stresses, you then move those stresses into the fatigue environment and do the fatigue calculation. So in that respect, fatigue is completely treated as a post-processing task. Moving those OP2 files, those stress files, and sometimes the intermediate files called FES files, can be quite a cumbersome task. With a solver embedded approach, with Nastran Embedded Fatigue, you have one single integrated process. Stresses are calculated and used as and when needed, but they're not stored and they're not moved. So we have one integrated process where fatigue and stress is calculated concurrently. This is significantly faster than the traditional approach. One recent analysis with a GUI-based run on a large car part took 44 hours with a GUI-based approach and 1.2 hours with a Nastran Embedded Fatigue approach. We don't need these intermediate files to be stored and to be transferred, and sometimes these files can be very significant in size. 200 gigabytes in size is not unknown. Moving those files then becomes very awkward and difficult. With Nastran Embedded Fatigue, with a solver embedded approach, you don't need those files. All you need is a single bulk data file input file, an ASCII input file. Of course, that's just a few megabytes in size. Once the job is run then, the output file is a standard results file, which would be, for a typical job, say 50 megabytes. So the maximum file size for a solver embedded approach might be 50 megabytes. The maximum file size for a conventional GUI-based approach might be 200 gigabytes. So significantly smaller file sizes. And because you don't need to generate those intermediate files, it's simpler. So not only do you not have to generate stress intermediate files, you don't need loading files to be defined in that way, and you don't need materials to be defined in that way. The whole thing is defined through a single input file. It's portable because everything goes into the bulk data file because the whole job is defined there. If you want to send the complete job to someone else in another country or another state, you simply send them the single ASCII file. This is significant in terms of portability and the ability to offshore analysis. The fact that the instructions needed for a fatigue job are also included in the bulk data file means that the definition of the whole job is very transparent. This is going to encourage far wider use of fatigue calculations in the overall process. I'm anticipating that a typical stress analyst will add the additional cards needed for a fatigue job, and he'll just request fatigue output as part of a standard stress job. So I think this is going to make significant improvements to ease of use and significantly wider use of fatigue calculations in the typical CAE process. And finally, optimization. Because optimization can be included in the fatigue job, it means that if, for example, if you have a car, full car body, and you want to optimize the thickness of certain panels, that can be included by setting fatigue as the constraint and optimizing for panel thickness. So this is a completely unique and new capability. Never before have we been able to really do optimization for fatigue. So this capability, Nastran embedded fatigue, is part of Nastran 2013. That's being released over the next few weeks. It's in beta state at the moment, so some people may already have tried it. To go along with this release, we're running a number of information days, the first of which will be in Turin on the 8th of April, followed by a number of events in the US starting 15th of April in Baltimore. We're also running, alongside these information days, we're running a number of training events, 3-day training events. And the first of these training events will be in Turin between the 9th and the 11th of April. Then there'll be an event in the US between the 22nd and the 24th of April. And then there's an event in India in May, an event in Sweden in May, something in Paris in June, and Germany in July, and then back in the US at Santa Ana in July. UK Frimley in September, and then 2 events back in the US in September and October. Thanks very much. If you need any more information on this product, please go to the website mscsoftware.com and you'll find full details of the capability.